This is the exam prep for exam 70-483, programming in C#. As you can see on the slide there, my name is Christopher Harrison. I'm a senior content developer with Microsoft Learning. I actually was a Microsoft certified trainer, although technically I still am. But I was full-time in the classroom for about 15 years with a couple of little breaks in the middle, focused mostly in on dev stuff, as well as some SQL and some SharePoint, and now, of course, on into Office 365. Then you'll notice my Twitter handle down at the very bottom, just in case you want to see more nonsense on Twitter. So as far as the basic outline goes, here's what we're going to wind up covering. Is we're going to get into technical content, and then we'll do some more technical content. And then we'll go ahead and talk about a little bit of exam stuff, and then we'll do more technical content. That the real goal here is to try and get in and start taking a look at the content that's going to be testable by the exam. And throughout this, I will scatter in different things that you are going to want to know about the exam process itself. But you are going to notice that my goal here is not to focus in on the exam process itself. So I will have little things like that, but it really is going to be a lot more about C#. Now, to dig a little bit deeper into that, what I'm not going to be able to do is I'm not going to be able to take you from not knowing anything about C# to being certified in 75 minutes. So if you're still calling it C#, I'm not going to be able to help you. Because A, it's not possible, and B, if it was, then the certification would be rather meaningless. So I'm making the assumption that everybody in here is familiar with C#, has been developing in C#. So my goal is really to try and touch on the different things that the exam is going to cover that maybe you haven't played around with a whole lot. So for example, one of the things that you probably noticed is testable by the exam is a little bit on security. So maybe you haven't done a whole lot with encryption. Well, let's go ahead and talk a little bit about encryption. Maybe you haven't written out to the event log in quite a while. Well, let's go ahead and talk about how to write out to the event log. So that really is going to be the goal here, is to try and get to those ancillary areas, which is very difficult apparently for me to say, and cover those rather than focused in on the mainstream. So you are going to notice that we're not going to do things like console write line. I'm not going to go over how to create a property. All of those are going to be assumed. The other thing that I am going to do is I am going to throw out sample questions. And the sample questions are 100% of my own creation. They are going to be multiple choice just because that's the easiest thing for me to do on a slide. Keep in mind, though, that when you go in to take the exam, you will see questions with drop-downs. You will see questions that will have you drag and drop, say, a series of steps and put something into order. You will have drag and drop where they will give you like a code snippet, and you'll have to drag the appropriate spots into the code snippet. So I don't have any of those types of questions just because they don't work really well on a slide, but you will see those. And again, these are, my questions. So they're not from the exam for obvious reasons, and they're not necessarily going to be indicative of what you see. They might be a little easier, they might be a little harder, just sort of depending on what's there. So the basic outline that I'm going to wind up covering here is really based off of the objective domain. That if you fire up Bing and you just simply do a search for 70-483, the first page that you're going to see right up at the very top is what's known as the objective domain, or as the cool kids call it, the OD. Now, on that OD, it's going to list everything on there that's considered testable. And if it's not on that OD, it's not considered testable. So if you're trying to figure out, okay, what do I need to know when going into the exam? That's what you want to check out. Check out that objective domain. And what it will do is it will list off everything that's going to be covered, and it will also give you some examples of different things. So it will give you the high-level topic, which I have listed here. It will give you lower-level topics, and then inside of there, it will give you may includes, just to provide a bit more information. People will often ask, hey, what do you use for studying? That's exactly what I use. Is I go into that OD and I'm just brutally honest with myself that if I don't understand something, then I'm going to get in and I'm going to start using it. One other very cool thing that you'll notice on the OD is additional resources. And that will be things like links to MSDN articles. That will be things like links to different books, to different online training guides or in-person events, and to things like Microsoft Virtual Academy. So that way, if you can't get enough of my really bad jokes, you can actually go watch me on MVA as well. The last little thing that I want to mention before I start digging into this is the fact that the 483 is basically the entry point for any of the certifications that revolve around C#. So that's obviously going to be the store apps. It's also going to be the web apps as well. That one of the things that the website doesn't show very well, if you go look at the web application MCSD, is the fact that 483 does work as an entry point. So if you've been looking at that and you see 480 and then 46, 47, which are HTML5, CSS, JavaScript, MVC, and then Azure and WCF respectively, and you're thinking, well, wait a minute, what about the 483? The 483 does serve as an entry point. Again, the website just doesn't show that really well. Okay. So there's the little roadmap slide, just so that way you can see all of that. And again, you'll notice the 480 is listed there, and just like I mentioned, 483 can be used for all of those. There's the link to the exam guide. Again, the skills measured, and if you want a full breakdown of what to expect on the exam, there you are, and it's basically each one of those sections pretty much evenly. Okay. So now let's get on into it. Let's go ahead and talk about our basic program flow. So let's talk a little bit about getting in and creating threads. So you are going to notice that .NET does give you the ability to create a thread object yourself. So you can just go in, say new thread, point it at the delegate that you want, say go, and away it will go for you from there. And the great part about that is that you get complete control over that thread. So if you tell .NET, hey .NET, I want you to create a thread, you know what it's going to do? Is it's going to create a thread. And if you need to control the name of it, if you need to cancel that, whatever it is that you want to be able to do to that thread, you want complete control over it, cool. You got it. That's the great advantage of doing your own threads. The great disadvantage of doing your own threads is that you get complete control over the thread. And again, if you tell .NET, create a thread, it's going to create a thread right then and there, even if it's not necessarily in your application's best interest. That, and fortunately, this mindset has I think, gone away from most developers. But I remember when garbage collection with both Java and .NET came into being, and a lot of developers kept saying, well, I can manage my memory better than a garbage collector can manage my memory. Probably not. Probably not. And the exact same thing holds true here. That you might be thinking, well, wait a minute, I can manage my thread better than .NET. Probably not. And one big thing to keep in mind whenever you get into the exam is you want to go with best practices, and you want to go with simplest thing that works. And so best practice, simplest thing that works, is not to go off and create your own thread. So if you do want a thread and you don't want a task, and we'll get into tasks and async in a couple of minutes here, then you can go ahead and take a look at the thread pool. And the way that the thread pool works is the CLR is going to manage a pool of threads, and how many threads are there are going to be based on your environment. So rather than you going off and creating a thread manually and .NET then adding on another thread, you just simply, hey, say thread pool. Can you do me a favor? Can you go ahead and run this delegate for me? And then .NET will go ahead and manage everything from there. So if it realizes that one thread is idle, it will go ahead and allow your work, your task to be executed. And if it realizes, well, wait a minute, we need to do some form of time splicing or anything like that, the thread pool will go ahead and manage that for you. The thread pool is going to be preferred over creating your threads manually. Now, an even better way to manage this is by utilizing a task. Now, a task is going to, just as it says right there, represent an asynchronous operation. And it really is just simply a wrapper around an action delegate. And an action delegate is going to take no parameters, can't have a state object, but it is going to take no parameters, and it can have a return type. And that return type is going to be a generic type when you go to create the task, or if you're creating an asynchronous method, then you're going to indicate public or private or whatever it is. So let's just say public, async, and then task, and then you'll have the generic return type on there. And then you go ahead and you build your method, and away you go to do your asynchronous work inside of there. Now, you are going to notice that tasks give you the ability to cancel the operation. Now, to cancel the operation takes just a little bit of work, takes a couple of different moving parts there. By the way, in the back, can you guys read the text okay? Is that big enough? Cool. All right. So what you're going to notice here is I've got a very basic little setup here where I'm going to, at the class level, declare 3 items. I'm going to declare my token source, and that's going to be what's responsible for allowing me to create a cancellation token. And it also is, and make a note of this, the object that I'm going to use if I want to say cancel this task. And that, I think, is a little bit counterintuitive, at least for my brain, that I would say, well, if I want to cancel the operation, that I should do that on the token rather than going back to the token source. But you call cancel on the token source, and as we're going to see in a couple of minutes, you check the token to see if a cancel has been requested. And then finally, last but not least, is we've got our task. Now, inside of the little click event, what you're going to notice is that we new up our token source, we grab our token, and then we go ahead and we go into our task factory, call new, and then we pass in do work, and we pass in the cancellation token. And my little do work method is down at the very bottom there, and I'll get to that in just a moment. So that start new is going to look for 2 parameters. The first parameter is going to be the name of the method or the delegate that you want it to actually start executing. And then the second parameter of the signature that I've called is going to be that cancellation token. Now, one little thing that you're going to notice here about do work is that do work doesn't accept any parameters. So you are going to need to make sure that it has some way to get a hold of the token. Because as you're going to see in a moment, it's going to need to check that token to see whether or not a cancellation has been requested. Now, if you wanted to pass it into some method, you can do that. It just requires that you create the method anonymously right inside of that start new. So just one little kind of workaround for that. All right. So inside of my do work, just kind of a very simple little setup. While 1 equals 1, which generally speaking is true. And you're going to notice that I'm just going to create a brand new little action and then call begin invoke to update my UI. Because remember that our do work is going to be on a separate thread because it's running as part of a task. And if this was running inside of a WPF app, which is exactly where I wrote this code, and we want to update the UI inside of a WPF app, remember you always need to be back on the main thread, thus the dispatcher begin invoke. So you're going to notice that I create the action, and then I call begin invoke to update my screen. I go ahead and I sleep for 100 milliseconds. I add my counter just for the little display. And then finally, last but not least, you're going to notice that I check to see whether or not a cancellation has been requested. Now, once you realize that a cancellation has been requested, it's then up to you to decide what to do to clean up. So if I wanted to go in and just display a real quick exit message, or if there was any resources that I needed to go ahead and release at this point or anything like that, then I could go ahead and do that here. In my very simple little example, all that I'm doing is just exiting out of the method. So you'll notice that the way that this is built is I'm just going to stay in this method until somebody clicks cancel. And when it comes time for somebody to hit cancel, you're going to notice that it's going to be token source.cancel. So you don't call cancel off of the token. Instead, what you're going to do is go to the token source and hit cancel there. Okay. Now, async and await. Async and await offer the absolute easiest way to handle asynchronous development. So any method that's marked as async, and remember that convention in .NET is any asynchronous method is going to end with the word async. An asynchronous method is going to either return void, meaning that we're not going to get anything back, or it's going to return some form of a task with a generic for the data type. My await keyword is going to be a little bit interesting. That when you look at await, and I want to say, let me just do it this way. Yeah, when you look at await, I always find await a little bit interesting. Because when you read the code, what you're going to notice is that I'm going to say, in this case here, string text result equals await, async result. And so it looks like at that point that I'm doing synchronous development. Because I'm now going in and I'm saying, hey, give me back a value. Especially if I had uncommented out this little line and I just simply called getString async. But what's actually happening when you call await is your code execution will pause. So line 13 is not going to get executed until line 11 completes. But what's actually going to happen behind the scenes is that .NET's going to say, OK, you're going to wait until that method's done. Well, if that method is currently idle, or if that method is currently working on some long process, I'm going to go ahead and I'm going to do that on the background. So I'm just going to put you off over here, and I'm going to keep doing work. And then finally, once that's done, then we'll go ahead and come back to life, bring it back to life, and away we go. So it's a very easy way for me to handle my development, because I basically just program as if it was synchronous. OK. Now, let's start up at the very top here. What you're going to notice is that if I want to use the await keyword, I need to decorate my method with async. The second thing that you're going to notice is, in my particular case, I'm just simply going to return void because I'm not going to send anything back. If you were going to return back an operation, that let's say that what I was trying to do here is I was just trying to create a wrapper around getString async, then what I would do is I would return data type of task generic string if I was just creating a wrapper here. Then what you're going to notice is I basically just simply new up an HTTP client. I then call getString async. Now, with my little var and async result, what that's going to do is that's going to return back the task. And so then I can, later on, I can do other work in the meantime. And then later on, what I can do is I can say, all right, well, let's go ahead and await. And then you'll notice the data type of string. When I say string, that's going to say, all right, I now actually want the data. I don't want the task. So if I had wanted to not do that little loading, please wait, let me just go in and edit this real quick here. And just sort of ignore the little comments there. There we go. So if I had wanted the string right away, that's the way that I write that. And so what will happen is the compiler will see that and will go, oh, OK, you don't want the task, you want the actual result. So I would also need an await there. Doing this on the fly. Await. There we go. OK. By the way, this little app that I'm using was actually developed as part of an Imagine Cup project. It's really kind of neat to throw into a PowerPoint deck. The color coding isn't perfect, as you're going to notice, like async and await aren't being picked up as keywords, but still a very neat little app. available for free. So just go into the Office store and just do a search for code, and it'll be like one of the first ones that you'll see there. In any event, so if I wanted the string back, then that's what I'm going to do. Is I'm just simply going to say string async result equals await, and then my call into get string async. That would get me the string right away. But if I know in advance that this is going to take a few minutes, and I'm thinking, hey, I need to do a little bit of work in the meantime here, then I can just simply, just like I originally had it, there we go, beautiful. Then what I can do is I can just simply say var async result equals. I can then do whatever other work it is. And then once I'm done doing my other work, I can then say, all right, well, let's go ahead and wait for that to be done. Again, that's going to be on a separate thread. And then once that comes back to me, then we can move on from there. OK. Now, my threads, my thread pools, my tasks, and my async await are all great when I'm trying to do one long-running operation. Well, what happens if I need to do a bunch of long-running operations? So let's imagine that I had a little helper method called, in this case, namecheck. And namecheck took a little while. So in this case, it's going to sleep for half a second, which, by the way, if you're a contractor, that's always great. Hey, this application is performing slow. Just go in, take out your little sleep commands. Yeah, you know? In any event, so it takes a half a second, and then what it's going to return is a Boolean based on the name, or the length of the name here. So in my case, length being greater than 5. So there's my little method. And so what I want to do is I want to use that method to filter out a list of names. So you'll notice that I've got a list of names there. And what I want to be able to do is I want to filter and only go grab the names that are longer than 5 characters. Now, there's actually 2 ways that we could do this. The second way I'm going to get to in just a moment. The first way is by utilizing parallel for or parallel for each. Now, parallel for each works just like the for each method on a normal collection. Now, what for each is going to look for is it's going to look for a delegate that's going to potentially return back a value, and it's going to accept a parameter of the type that's inside the list. So if you have a list of strings, it's going to be looking for a string. The catch with parallel for each is that it's not attached to a list. It's not attached to a collection. So the first parameter is, hey, what collection do you want me to iterate over? And then the second parameter is going to be some form of a delegate here. And in my case, what I'm doing is I'm building up an anonymous method by using a lambda statement, which, by the way, make sure that you know your lambda statements. Make sure that you know your lambda statements going in. So what you're going to notice is I build that up inside of a lambda statement. I call my name check. If it turns out that it's true, go ahead and just add that into my second list. And then you're going to notice down below that I'm just going to print out the names of everything inside of there. So parallel for each. Now, the way that parallel for each is going to work is it's going to look at the number of cores that are available and spin up X number of threads where X is the number of cores. So if you have 6 cores, it's just going to be able to spin up 6 threads and work through all of your data asynchronously that way. Now, the other way that we could do that is highlighted in this little question right here. So you have the following code. var items equals new list string, and then my little names. And then I have var results equals items.where, and by the way, make sure that you know how to write link queries. And then I've got my little method 1. And then for each, and then I go ahead and I display out. Now remember, of course, that when you set up a where statement, if I go ahead and I call another method, that method has to return a Boolean value, so we automatically know that. So we know it's going to return a Boolean. And what it does behind the scenes really doesn't matter, but you'll notice that it gives us the additional information that method 1 takes several seconds to complete. You need to make sure that your code executes in the shortest amount of time possible what should you do? So we've got possible answers there. What do we like? I hear C. I'm not saying C is right or wrong. I'm just simply stating I hear C. You're going to say C's right. Okay. Anybody else? A lot of people are still tired from the party last night. The correct answer is C. That what as parallel is going to do for me, there we go. What as parallel is going to do for me is it's going to convert that collection into a parallel object. And then from there, all of the link commands that you call are going to execute using that exact same parallel technology from, say, for example, parallel for each. Now, there's a couple little things that I want to highlight about this particular question. First of all, is you're going to notice the basic structure. And this is something that you will see on almost every question. You have, here's your scenario. You need, here's your problem. What should you do? And that will go ahead and fix the problem. You're also going to notice the little line right here, you need to ensure your code executes in the shortest amount of time possible. That's going to come up quite frequently. So you are going to need to know, to a certain extent, what way is faster than another. Now, it's not going to give you something like, trying to think of a real good example, and one's not coming to me. But it's not going to be something where you're going to be splitting hairs. It's not going to be anything like that. Like maybe the difference between doing a console write line, doing a console write, and then putting in the carriage return inside of there. Like, is that going to be a performance difference? Who knows? And if it is, it's probably going to make zero difference in the long run. So it's not going to be anything like that, but it's going to be something where it makes a huge difference. So that's the first big thing. So you're going to notice all of that. The second thing is, as you take a look through the different possible answers here, is whenever you see a full line of code as part of a question, it has to compile. So all of these will actually compile, and that's actually, I think, where as parallel gets a little bit confusing. Because the thing about as parallel is that it will actually work on any collection, and when I call where, you know what that's going to return back to me? A collection. So I absolutely could call as parallel there, but here's the thing, is it's of course going to be executed in order, so items where, it's going to go ahead and run our method 1, and then we're going to call as parallel after that. Well, it's already executed. Who cares if it's parallel at that point? Which is why C is the right answer. Cool. All right. You have a method that accesses a database using the following code. You are going to notice that periodically they will throw in an ellipse, and the ellipse is just simply an indication that, hey, look, there's additional code here, and the code does not matter for the question. So there's my little try, there's my little catch, and then down at the very bottom, you need to ensure the original exception is thrown back to the caller. What code should you add to line 7? And everybody likes A. I'm not going to hold you guys out in suspense here, and the correct answer is A. That, again, the difference between A and B, and it's so subtle, is that A will take the current exception and just toss that right back, keeping the original stack trace in place. What B is going to wind up doing is it's going to say, oh, look, you're throwing an exception from here. And so the stack trace is going to be reset at that point. So it's a very subtle difference, but it makes a huge difference whenever you're doing exception management. Okay, let's go ahead and take a look at creating and using types here. And I did mention the fact that I'm not going to get in and dig deep into the basics of creating classes and so forth. But there are a couple of little things that I always like to highlight about classes, because this is one of those things that a lot of developers will learn when they first learn C#, and then don't necessarily find themselves going back to on a regular basis. And this will be something that is testable. So you're going to notice that I've got a basic little class there called default constructor. And so what that will do, just like the name implies, is that will create a default parameterless constructor. So when I do my compilation, it will automatically throw in a constructor for me. Now, if I write my code like this, and I go in and I say private constructor, the moment that you add any constructor, and that could be a constructor with parameters, that could be a constructor like I have here that's parameterless, the moment that you do that, the compiler will not create a constructor for you. Now, where this becomes a little bit tricky is that if you're going to inherit from a class, you need to be able to create a brand new instance of that class by calling its constructor. And as we all know, the only class that could call its own private method is itself. I've got a private constructor. If I inherit from this, the derived class is not going to be able to construct an instance of that base. So what's going to wind up happening here is when you go in and you try to inherit, it's going to give you a compiler error saying, hey, look, we can't call private constructor because of its accessibility level. All right. Now, if I scroll on down, you're also going to notice that I've got another little class here called custom constructor that has, just as the name implies, custom constructor takes a string. And you are going to notice, again, no default constructor is created. Here's the catch. If I want to inherit from that, then once again, I need to be able to create an instance of that. So if I just simply, and there we go. Okay then. It's like a 4-year-old grabbed a crayon on a wall. All right. In any event, if I left off that base down at the very bottom, I know it's not showing up really well, but if I left off that base down at the very bottom, this would actually give me a compiler error. Because what's going to happen is it's going to, again, try to create an instance of custom constructor. It's going to realize, wait a minute, there's no default. And it's not going to know how to call that custom constructor that I created. And so as a result, it's going to fail out on me when I go to compile. Now, all right, well, and it's just now going to draw even if I'm not clicking down. In any event, so if I now want to inherit from that, what I need to do is I need to say this is the constructor that I'm going to call and this is the parameter that I'm going to pass in, because of course the compiler is not going to know. The compiler is not going to know what parameter or what value to pass in for name. So you have to go in and provide that. And again, the way that you do that is by using that colon base syntax. Okay, cool. Now this is another one of those little spots where chances are you're very used to, very familiar with saying list string equals new list string. But maybe you haven't spent a whole lot of time creating classes or creating methods that use generics. Which, by the way, is a real quick aside here. If you haven't spent a lot of time doing that, it's amazing the amount of time and the amount of code that you can save by using this. It's so extremely powerful. In any event, what you're going to notice is I've got the bit of syntax up here. So public class, class 1 with T1. So T1 is now going to be my generic. Inside of this class, I can use T1 just like I could string or int or SQLDB connection or any other class that's available to me. Now, the problem with just simply saying T1 by default is that somebody could actually pass in whatever class type it is that they might want. Sometimes I need to be able to do a little bit more work with it. So, for example, maybe I need to make sure that it's an object, that it's a reference type. Maybe I need to make sure that it has a default constructor. And that's exactly what I've got there, that where class comma new, class is going to indicate this must be a reference type, and new means that it must have a default constructor. And so going down to line 8, that's what allows me to say T1 item equals new T1. If I didn't say where T1 colon new paren paren, I wouldn't be able to write line 8 because it wouldn't know in advance whether or not there was actually a parameterless constructor. Now the second thing is, well, what happens if I want the ability to actually call methods? Well, if you want to call methods, then you need to constrain the data type and indicate that it must inherit or implement some class or interface respectively. And again, the way that you do that is by saying where the actual value, colon, and then in my case, iClonable. And so what that means, the moment I say iClonable, is that I know that the clone method is going to be there, and that's what allows for line 9. Yeah?
So with the default constructor of the class, is that just saying that it has a default constructor, or can you extend that out to say this class must have this particular method? Is that foo paren to guarantee that the T1 will be foo?
So to answer the first part of that, I can say that it must have a parameterless constructor by using that syntax. The second part, and it can be parameterless, so it doesn't have to be a default constructor. And again, I know this is being a little bit pedantic, but the difference is that the default constructor is the one that is automatically created. So it could be parameterless, so it could have logic inside of there, just no parameters. As far as me telling it has to have a specific method, I can't do that directly. But if it's inside of an interface, then I can say it must implement that interface. You're welcome. Okay. Cool. So along those lines, you create a class using the following code, public class, class 1. You add the following method to a class named class 2. So using var class 1 equals new class 1, and then my paren paren, and then down at the very bottom, you need to ensure that class 1 functions correctly in the using statement. What interface should you implement? And yeah, whatever iDisposable is. Okay, so B. So a couple of real quick things that I want to mention here. Number one is if you take a look at this particular OD, you are going to notice that it really is just all about creating basic types. And that's actually why I've only got the couple 3 slides there. It's just because a lot of that, when you go in and look at it, that's sort of, pretty straightforward. That's something that most everybody's wound up doing. But again, you are going to be responsible for knowing that as part of the exam. Now, sometimes when people look at that and they see the one particular section in there that says, hey, wait a minute, they'll say, hey, wait a minute, this lists off a bunch of interfaces. Am I supposed to now memorize every single .NET interface? And the answer is no. That the goal here is, do you know the big ones? So do you know iEquitable? Do you know iComparable? Do you know iComparer? Do you know iDisposable? So all of the big ones are the ones that you're going to need to know. And you'll also need to know how to implement all of those. So if it's been a little while, for example, since you've done equals, if it's been a little while since you've implemented the proper pattern for iDisposable, time to go back and take another look at how to do that. Now, the other really big thing here is that all interfaces and other methods and classes and so forth must exist. So I mentioned earlier that if there's a line of code there it has to compile, to go one step further here, it has to exist. So one of the interfaces that they could not list here as a distractor would be iUsing, because it's just not fair. So has to exist. So iDisposable. Yeah. Does it? Oh. I'm going to fire my editor. There we go. Beautiful. Okay, you have the following code, yada, yada, yada. You need to add string 1 to collection 1. What lines of code should you use? Choose 2. Each answer represents part of the solution. Now, while you guys are reading this, the one thing that I do want to mention is you will see something like choose X you will see something like choose all that apply. Now, the real key, I always find this very helpful, is to read the next sentence. Because it will say either each answer represents a complete solution or each answer represents part of the solution. And what I like about that is that it helps frame everything else. Okay, so what do I need to do with this? How do I actually add my code in? So I hear C and D, and that is the correct answer. So, come on, there we go. The reason that D is correct is pretty obvious. We all kind of figured that one out. The reason that C is correct is because remember that by default, the default constructor is going to initialize everything to 0, null, false. So all of the number types are going to be 0. The Boolean types are going to be false. And everything else is going to be null. So in this particular case, that list doesn't exist. So if I want that to exist, I must construct it. Otherwise, I would get a null reference exception. One very important tip here, strings are reference types. Strings are nullable. So the default constructor is going to set that to null, not an empty string. All right. Now, let's talk a little bit about debugging and implementing security here. So we've got two types of encryption that we could use, and we've got hashing. So we've got symmetric encryption, which is reversible encryption with a single key. So the exact same key that you use to lock the deadbolt when you leave the house is the exact same key that you're going to use when you go to leave. So I've got my little basic text of hello world. This is now an official development presentation. We put out hello world. There we go. So we go ahead and we encrypt that to some random bit of characters that happened as I punched on the keyboard. And then again, we can come back to hello world once we're done. Now, what you're going to notice is the list of symmetric algorithms. There used to be what was known as an 80-80 rule, which is basically to say that 80% of developers or people using a particular product are doing this 80% of the time. And the basic concept behind that was, let's not test trivia. That's not the goal here. That what we're trying to do with the certification process is to make sure that if you pass this, that's saying, yeah, you know what, I'm qualified to hold a position. I'm qualified for this job. That's the goal here. And so testing trivia doesn't help towards that goal. So along those lines, real quick show of hands, how many people in here have actually written out the .NET code to encrypt and decrypt a string? Okay, I've got 4, 5 people, sort of a sixth, a little bit, that's raised their hand, and that's about it. So obviously this is not something that's done very often. It's something that you absolutely should be aware of. It's something that you should know. But obviously getting it and writing the code, not something that a lot of people find themselves doing. So you are going to notice, as far as the exam goes, don't study up on how to go in and start doing all sorts of encryption, decryption, and all of that. But be familiar with kind of a where to start. So if I needed to encrypt a class, if I needed to encrypt a string, if I needed to decrypt a string, what are the moving parts? What classes do I need to know? What algorithms do I need to know? And so you're going to notice here that I've listed off 3 of the different algorithms for symmetric. And then you'll also notice, if you grab the slide deck and you hit that link, that this will actually take you to the MSDN article for symmetric algorithm and list off all the algorithms that are available. And along those lines, our asymmetric encryption is going to be that reversible. It's going to be that 2 keys, public, private, one locks, the other one unlocks. And you're also going to notice here our asymmetric algorithm, and you're going to notice the available asymmetric algorithms here. The other real quick thing to highlight is know when to choose one particular operation over another. So I want to encrypt data when I'm looking for the ability to protect it, and then be able to pull that back out again. Contrast that with hashing. So hashing is irreversible, meaning that we're not going to be able to get that back. So when I take hello world and I convert it into that, I'm not going to have the ability to bring that back to hello world. So if I need to write some data out to a file and be able to read that back in, that's perfect for encryption. And if I need to store a password, that's where hashing comes into play. Because I don't want to give somebody the ability to reverse that back out. Now, yes, if we want to start getting technical, I should salt and then hash my passwords. We're not going to dig that deep in, but there you have it. And so again, you're going to notice the different hash algorithms. The two that I always like to point out, MD5 and SHA, the moment you see those, that's going to be our hashing algorithms. Okay. So serialize, deserialize. Let me go ahead and increase the size here, and let me open up my, my employee. And for whatever reason, it's just not displaying my data contract on top of that. But just imagine that there was a data contract attribute on top of employee. So what you're going to notice with serialize and deserialize, first of all, out of the box, you can serialize, deserialize any object. The second thing is, if you do want more control over it, then what you're going to do is utilize data contract and then our data member. And what you can do with the data member is indicate whether or not you want it to be required, but you can also use this to change the names. So that way, when we go to serialize this out to JSON, when we go to serialize this out to XML, I have the ability to change those names. By the way, I have to say that Jason is a heck of a guy. These are the jokes. They're not going to get any better. Lower your expectations. Okay. In any event, to then go in and take a look at the basic structure here, what you're going to notice that I new up an employee, I go ahead and I create a memory stream, and then you're going to notice that I use my data contract, JSON serializer, so it's going to look at that data contract. I have to tell it the data type, and then I go ahead and I call write object, which is going to look for the stream, and then the object that we now want to encrypt. Now, you're going to notice that I'm sort of taking a couple of little liberties here, just for the demo's sake, that I'm just going to keep using the exact same stream over and over and over again in this. So I just set the position back to 0, which just puts it at the very beginning, and that allows me to then deserialize. Now, to print out the data, you're going to notice that I'm just going to use a stream reader and then write that out. That would actually print out my, my JSON code. And then what you're going to notice is that I reset it, and then when I want to read the data back, I'm going to use read object. I'm going to convert that into my employee, and then I could go ahead and print that data back out. If you actually copied and pasted this code into Visual Studio and ran this, it would go ahead and print out the JSON code, and then it would go ahead and print out my object down at the very bottom. So the basic syntax for doing our serialization and our deserialization. Another big one that a lot of people don't find themselves doing an awful lot is writing out to the event log. If you are going to write out to the event log, the first thing that you need to know is the source, which is going to be the event log that you want to write out to. You can always write out to application. You don't need any special permissions to write out to application. So generally speaking, that's where you want to write out to. If you need to go in and create your own log inside of there, then what you're going to need to do is call create event source, which is a static method off of event log. You will need to be an administrator to be able to call that. And then finally, last but not least, is to just simply call write entry, which is going to be our string. It's going to be the data type. So in this case, I've chosen error. And then you can also specify an ID or a code number to go along with that. Now, another big thing is to do tracing. And the way that we're going to do tracing is we need to identify two main items. The first big thing that we need to identify whenever we're doing tracing is where do we want to write the data to? And that's going to be our listener. And so what you're going to notice is that I've set up our listener. This is going to be a console trace listener. You can also write out to the event log. You can also write out to XML. And by the way, always keep in mind simplest thing that works. That whenever you're taking an exam, simplest thing that works. So, for example, let's say that I'm looking at a question that says, hey, you need to write errors out to an XML file. What should you do? And it offers you the opportunity to create an instance of XML writer and start doing create or write begin element and end element and all of that good stuff. Or it gives you the opportunity just to use tracing. Simplest thing that works, use tracing. All right. So that's the first big thing, is I have to identify where it is that I want to write it out to. The second thing that I need to identify is my switch, and this is going to be the level that you want to write out to, which is going to be verbose, informational, warning, and error. Now, the way that the switches work is that the lower ones, as I've listed them here, are going to automatically include all of the higher ones. So in other words, strike that, reverse it. The higher one is going to include all the lower ones. So in other words, if I say verbose, that's going to include anything that's been flagged as verbose, information, warning, and error. If I say warning, that would only include warning and error. Now, both of those items, my listener and my switch, are balled up inside of a source. So when I go to actually write out to that, all that I need to do is identify the name of the source. So you're going to notice that I've said new trace source, demo source. If I kick back over here, you're going to notice my source name was demo source. I'm very creative in my naming when I put my slides together. Okay. So you're going to notice there that I create that new source. And so now, that has both the listener as well as the switch. So it knows where to write, and it knows what to write. And so what's cool is that I could, if I wanted to, just write out to any listener that I've identified. And so you'll notice that I chose console. And if I come back over here, you're going to notice I said add name equals console. So I've defined a listener. So if you want to write explicitly to one listener, you could do that. Typically, though, you're going to write out to a source. And so what you'll do is you'll identify an ID, you'll identify whatever your message is, and then you'll identify the particular level, warning or verbose. Now, this code can stay there. And it's going to be the config file that's going to define my switch, or going to define my tracing level. So in this particular example, I said warning and I said verbose. If you remember, we went in and we set up our switch with value of warning. And so as a result, we would see our warning message. We would not see our verbose message. If I change that to be verbose, we would then see both the verbose and the warning message, in this case, written out to the console. Now, you could also go in and do all of that programmatically as well. So if you didn't have that inside the config file, you're going to notice that you can just create that trace source. So I am going to need the switch, so give it a name, specify the level. I'm going to set that on my source, and then you're also going to notice that I need to specify my listener. So you'll notice those two little items there. And if it did turn out, by the way, that you did have this programmatically and you wanted to name that listener, you're going to notice that you also have the ability to do that as well. So the key here that I want you to notice is that I could do this with a config file, which generally speaking is the preferred way to do it. Or you can also do it programmatically, but regardless of which way you do it, it's going to be the source that I write out to. That source is going to be the container for both the listener or listeners, could be plural, as well as my switch. Cool. Now, another one of those cool little things that are available that not necessarily a lot of people find themselves using is compiler directives. So with a compiler directive, you define a particular flag, and then you can test for its existence by saying #def and look for that particular flag. And then if it turns out that it's there, then that code will be included as part of the operation. And if the flag isn't there, then it won't be included. Now, one little side note on that is CSC, the compiler, doesn't actually offer conditional compilation in the truest sense. So if I just went in and I said if demo flag and I just typed out wibble, something that it's not going to compile, it would not compile. So that code is still going to be analyzed. Code still has to be compilable. But if I don't have the define flag or demo flag defined, then console write line would not become part of the compiled output. So it would have to be compilable. So what my flag determines is whether or not that's going to be included. The other real quick two things that you can do is you can also use warning and error. So if you want to add your own compiler warning, you can do that by saying pound warning. And if you actually wanted to add your own error in, which will behave just like a normal compiler error, meaning that it would not compile, then you could go in and say pound error and then compiler error. All right. Last but not least is getting in and implementing data access. Again, one of those little things that not a lot of people find themselves doing is going in and reading streams. So you'll notice the basic syntax for going in and reading a stream. So I'm pointing to demo.txt. What else would I point to? And then we go in and we identify how big of a buffer. So that's going to be the chunks. We go ahead and we grab our file stream. You will want to know the different modes that are available and the difference between each one of those. And then inside of my loop, you'll notice the way that read works. And this is one of those where if you don't do it all that often, you always have to stop and go look it back up. Make sure that you look it up real quick. And you'll notice the way that read works is it's going to look for my buffer, so my array of bytes. It wants to know, well, where do you want to start? And then how many bytes do you want to go get? Now, I said 1024. Here's the catch. What happens if there's only 3 characters left? So it's obviously not going to grab 1024, so that read is going to tell me the number of characters that it actually retrieved. So then I can go ahead and convert my data into a string by giving it the byte array, specifying the start point, and then specifying how many characters to do. I know how many characters because read returned that back. I can then go ahead and print that out. And as long as we keep grabbing 1024, we're good. The moment you grab something less than 1024, that tells us that we're at the end of the file. One little exam tip here, if you don't mind, and that is that you are obviously not allowed to take a book or your laptop in, obviously, but you are allowed to scratch a piece of paper. And once the test starts, you're allowed to do whatever it is that you want with that scratch piece of paper. So if you want to start writing out your memoirs, go for it. It's probably not going to help you, but you could do it. But one thing that will help you is this, is there are certain things that if you don't do all that often, tend to just go right out of your brain. So just before you walk into the exam, what you could do is go ahead and open that up, take a real quick look, and go, okay, I know exactly what that is. Then you go and you sit down, and then just write it out on the piece of paper. And what's great about that is you're going to do that before you're looking at a question. That one of the things that's just universally true is we as humans, we tend to get, well, frankly, a little dumber whenever we're under pressure. True story. We all do. And so if you're doing that before you're looking at a question, before you're under any pressure, the moment that you actually now get to the question, all you have to do is look at your piece of paper. So I can write it out before I'm stressed, and then once I am stressed, all I have to do is read. All right. Come on. There we go. All right. Now, as far as reading out our streams go, actually, no, this isn't a streams. This is a link. My slide title is wrong. Okay. So let's go in and take a real quick look here. I've got 2 very basic classes. I've got a category and a product. Please don't nitpick on this. I know that I don't have things like product ID and so forth. That's not my point. So I've got a category and I've got a product. So I've got my obvious parent-child relationship here. Now, what I want to do is I want to join these together by utilizing LINQ. I mentioned earlier, and now we're actually going to get into it, that you will need to know LINQ queries. everybody here knows how to do from X in collection where order by select X. When you start getting into doing joins, when you start getting into doing group by, that's usually where things start to go a little bit sideways. So here's our basic little setup there. There's our category and our product. And if we take a look at our program here, you're going to notice that I've got two little methods. One for get products, which is just going to return back a list of products. What it returns is sort of irrelevant, but there it is. And again, if you grab my deck, you can see all the rest of the code there. And then you're also going to notice that I've got a brand new list of categories. So I've got my products and I've got my categories, and those are all going to be created out there. The thing that I want to highlight is down here, and that's going to be to do the actual join. Okay. So what you're going to notice is that I set up my categories, I set up my products. And then I'm going to say, inside of my link query, I'm going to say from C in categories. So again, just your standard. And then when I want to do the join, what I'm going to do is I'm going to bring that in almost as if I was doing kind of a normal link query. But instead of saying from, I'm going to say join. And so now I'm going to identify my second table. So I'm going to say join P in products. And then just like SQL, you're going to have an on statement. But unlike SQL, unlike I think almost anywhere else inside of C#, you're not going to use an equals operator or a traditional one. So you're going to notice there is no double equals there. But instead, it's the keyword equals. So it really is just like doing a normal join like you would inside of SQL. So it's going to be from C in categories, join P in products, on, and then our C category ID equals P category ID. And then finally, down at the very bottom, you're going to notice that I'm going to create an anonymous object because I would have a little bit of a problem here because my name is inside of a property called name and my name is inside of a property called name, like it should be. That creates a little bit of a confusion point, and so now I can return back my individual objects, which would be my individual values, which I'm going to put inside of category name and product name. Now, what join will do is join will do a join just like a normal SQL join statement, meaning that's going to give me a single table. So I can loop through this just like I would a single table. So you're going to notice that I've got my basic for each, and then I simply print out to the console, and the end result would look a little bit like that. Now, coming back to our little program here, and let me scroll on down, let's take a look at group by. Now, group by is a little bit tricky, because the way that our grouping is going to work is we're going to create groups. We're going to sort of create multiple tables so that each group is going to have some form of a header and then data to go with it. And then some form of a header and then data to go with it. And so that's exactly what I've got right here. Is I'm going to say from P in products group by, and in this particular case, the category ID. And I need to now put that into a new grouped table. That grouped table is going to have a key for each of the groups that were created. And then it's going to need some bit of data to be inside of there. And that's going to be represented, in this case, by G. So this is going to identify the group. This is going to be the data inside of the group. And so you're going to notice when I get in and dig in here that we essentially have two tables. That the first table that I've got is going to be my groups. And then the second is going to be each group. So I loop through my groups on the outside, and then on the inside, I loop through the data that's inside of that group, which in this case is going to be my products. And so the display there is going to be our group key and then our grouped data from there. Okay. So you can actually identify kind of whatever it is that you want it to be. The group key is just going to be an auto count number, but you could go in and make it something else if you so desired. You would just simply do that as part of your select statement when you return it back. Yep. Okay. So you are creating an app that will process orders. You need to ensure that all orders are processed in the order in which they are received. What collection type should you use? Hash table, dictionary, stack, queue. Okay, the answer is queue. Now, let me ask you a question. In theory, could I use a hash table for this? Yeah, absolutely. I could use a hash table, I could use a dictionary, I could use a stack. Stack would be a little bit trickier, but you could do it. It could be done. It could, because you could do a lot of peeking, and it would just get really, really messy. So could you do it? The answer is yes. But again, simplest thing that works, or go with the obvious, you know, and that's going to be our queue. All right. You have the following code. So there's our list. There's our little result. We've got a for each. We go in, we say add, and we've got a for each. And then down towards the very bottom, it says you need to ensure both for each loops display the same data. What should you do? And it gives you the possible answers there. Now, I'm going to say something. This would actually be sort of a bad question, that if I was actually writing this question, this is sort of a bad one, because I'm actually teaching you something here. Now, what I'm teaching you, I'm telling you right up front, hey, look, those two displays are going to be different. So you already know that there's something that's a little bit amiss here. And the reason that I built it this way is just because, well, I had to fit it onto one slide. This was sort of the easiest way to have a question and talk about my point. Now, the point, of course, is that whenever you're doing link queries, that your link queries by default are deferred. Meaning that they're not actually going to be executed until you do something with the data, which in this case is going to be done on lines 4 and 8, our two for each loops. And so it's going to execute the query, give me the results, print all the data out. And then I modify the list. And then I go back and I do something with the query. I really need to fire my editor. Shh, don't give that away. Okay, yeah, there we go. I am my own editor. It shows. In any event, this is why test-driven development is a good thing. Okay, so in any event, your queries are going to be deferred. So what's going to wind up happening on lines 4 and 8 is that the query is going to get executed and the query is going to get executed. And then in that middle there, that line 7, I go in and I say add 5 to the list. Well, when I re-execute that query, it's now going to go back and look at the list again. And that list now has one new value. And so it's going to execute that where statement greater than 3, so that value would wind up coming back. So how do we go in and solve this? Well, the way that we solve this is, and I'm not going to go to the next slide because I know that it's still got the little error on there. But the way that we're going to solve this is by going in and calling toList right after our where statement. So the moment that you call toList, you're now going to say convert that to a list. It's going to execute the query, and it's now going to give me that I enumerable actual result. So in that particular case, it would just display 4 each time.
You get a warning in that scenario that Visual Studio would say multiple evaluation on the second one, right?
You might have an add-on for that. Like if you're using a refactor, it will give you that. I don't believe that the default compiler, and I could be wrong on that, and if anybody else knows the right answer to that.
We use ReSharper.
Okay, yeah, I'm willing to bet that's actually what's doing it. Yep. Okay, cool. So with that, what you're going to notice is all of the different resources that are available for you to go in and check out. If my slides are not on the TechEd site, you could actually just find me on Twitter at GeekTrainer, and I'm more than happy to go ahead and share my decks out with you from there. Yeah.
Will the exam cover any of the
So the question is, will it cover any of the 6.0 features? And the best thing to do is to go look at the objective domain and take a look at when the last date was that it was edited, because that will basically create your cutoff point for you as far as when when content was last created. So go take a look at that, and you'll be all set. Cool. So with that, the last little thing that I'm going to say is don't be afraid of the exam. Remember that if you fail, nobody's going to come down, hit you with a stick. So, you know, all that's going to happen is just going to display little screens. It's not even going to print out a piece of paper anymore. It's just going to display a little screen, just simply saying, hey, you failed. You'll be able to go back, take it again. Trust me, you know, the car will still start and all that good stuff. So with that, I do want to thank you guys. If my slides aren't up on Ignite, you can go ahead and find me on Twitter and enjoy the last little bit of Ignite. So cheers. Thanks a lot.